to 11-4 and take a look at 11.3, and it's basically the same as 11.1 except that, and please keep this in mind as you do some of these. You kind of read, it says note, use the 6-step hypothesis testing procedure to solve the following exercise, and that's just up above. You know, that page on 354 there, it says A, B, C, D, E, F, right, where you state the null hypothesis and the alternate hypothesis. What's the decision rule? What's the value of the test statistic? What is your decision regarding the null hypothesis? What is the p-value? And interpret the result. So we have to, okay, A, B, C. So first, state the null hypothesis. Well, we got to read the question first. Gibbs Baby Food Company wishes to compare the weight gain of infants using its brand versus its competitors. A sample of 40 babies using the Gibbs product revealed a mean weight gain of 7.6 pounds in the first 3 months after birth. For the Gibbs brand, the population standard deviation of the sample is 2.3 pounds. A sample of 55 babies using the competitor's brand revealed a mean increase in weight of 8.1 pounds. Ooh, it's bigger. The population standard deviation is 2.9 pounds. It's also bigger. At the 0.05 significance level, can we conclude that babies using the Gibbs brand gained less weight? Okay, again, I like to go to the alternate hypothesis then, and oftentimes that significant statement, most oftentimes, says, can we conclude the babies using the Gibbs brand gained less weight? So I can say, can we include that the mu1, which is the Gibbs mu, right, or the Gibbs mean, is less than mu2, okay, which makes our null hypothesis that mu1 is greater than or equal to mu2, okay, and that's always the case as you're stating these hypotheses. You know, if this one is a less than, then this one has to be greater than or equal to. Likewise, if this is greater than, okay, and you might have some, I can't remember if in the future we might have some of these that are less than or equal to, in which case this would be greater than, okay, but they're always kind of the opposite like that. So we get the 0.05 significance level, and remember though that this is now what type of a test? Well, it's a one tail test, right? And by the way, you can state this as H sub O and call this mu1 is greater than or equal to. Right, it might be a little easier to type those things out like that than trying to find those symbols like I did. So then the decision rule is we're going to reject if the z is less than, right? So we're going to reject, accept the alternate hypothesis if z is less than, and then this is going to be a minus, and so we got to look that up, right? Our 0.05 significance, but it's one-tailed, okay, so if it's one-tailed, then we come out here to 49, right? 49 exactly, if I can get there. Oh, that's pretty close. Ooh, wait. I'm 45. Shame on me. Yeah. Shame on me. Okay, 164 and 165, somewhere in that neighborhood. I think they use 165, 1645. I interpolated, okay, minus 1.645, and I might have got that from doing this as well, but it would be an interpolation just as well using the chart, okay. So then we go and we do our math, and again, I won't belabor you with the math. I kind of break it up and I do the the variance of the two samples, and then I do the square root of that, which gives me the bottom part of the equation. The top part of the equation is pretty easy. It's the mean of the 1 minus the mean of 2. In this case, it's a negative, okay, and my square root, and I come up with a minus 0.936. Well, that's not less than, that's greater than, right? Yeah, that's greater than minus 1. So I fail to reject the null, okay, because it's greater than mu sub 1. I guess when I calculate the z, it's greater than this, and so I fail to reject the null. I accept the alternate hypothesis, okay. So I cannot conclude that Gibbs babies gained less weight. Ooh, let me see if that's right. Again, I got to think about that. Yeah, I cannot reject the null, so I can't I can't say that they well, just like I put in my decision, I cannot conclude. So I fail to reject the null, so I do reject the alternate. I think that's the part I said wrong. I reject the alternate that mu sub 1 is less than, that the gain's babies are less than the competitor's babies. Okay, I do reject the alternate, but I fail to reject the null. I can't say that I accept the null. I can never say that. Okay, I find a p-value of 0.17. Again, this is 0.5. I look up my 0.936, somewhere's in that neighborhood. We'll go look that up, right? On my z-value, 0.93, 0.94, it'd probably be a little closer, right? Oops. Somewhere's right about that. It's hard to get there. Oh, this is just mean sometimes. So 0.5 minus that, right? Because then I'm dealing with this area that's over here. So 17.36, right? 17.36 or 0.1736 is what I found. So my p-value kind of corroborates that, but it says that, hey, you know, there's still a chance, you know, 17.36% chance that the babies did gain less weight. But there's an 83% chance that it's statistically insignificant. It's basically what we're saying there. Alrighty.